Hi, and welcome to Chapter 4, Section 4, and we're learning a big deal definition here. Say hello to your new best friend. That is CPCTC. What that stands for is corresponding parts of congruent triangles are congruent, and this of course is based upon the definition of congruent triangles, which says that all of the corresponding angles and all of the corresponding sides will be congruent to each other. So we're going to go ahead and fill in this first proof that's on page 1. You'll notice that your givens are that AB is parallel to DC. They've already marked it in the picture. I'm going to go ahead and just make those lines red. We've also been told that angle B is congruent to angle D, and we're trying to prove segment BC is congruent to segment AD. So I take a look at the picture and I say, those sides are part of two triangles. If I can prove those triangles congruent, then I know their parts will be congruent. So let's go ahead and walk through the proof. So we take the first given, that the lines are parallel. Anytime the lines are parallel, you're looking for special angles. So the step says angle BAC is congruent to angle DCA. Do you remember the reason for that? Exactly. Interior angle theorem. Then the second given of angle B congruent to angle D. You'll now notice we have two pairs of congruent angles. So if I could get side AB congruent to side DC, I could use angle side angle, but I have no reason for those two to be equal to each other. I do, though, have the reflexive side right here of segment AC congruent to segment CA. They reversed it. You're welcome to say AC is congruent to AC. Either way, your reason is the reflexive property. At that point, if you take a look at the markings on the picture, you have angle side marked on both pictures, and again they went ahead and wrote the correspondences and gave you the congruent statement. So this is angle side theorem. Now at that point, because I know the triangles are congruent, I know all of their parts are congruent, corresponding parts. So the corresponding parts we're using are BC and DA. Notice how you can see that they go together by their location in the congruent statement. So the reason we can say that is CPCTC. Corresponding parts of congruent triangles are congruent. We're going to do one more example together on page 2. So let's go ahead and head over to page 2. So on page 2, we're looking at example number 1. And again, after reading the givens, you check, and yes, they were very kind to you, and they also have marked the givens. And I went ahead and wrote the first step, and again, we know where we were getting started. Then we take a look. We're trying to prove angle N is congruent to angle P. Once again, I have no reason unless I can prove that those two triangles are congruent to each other, then N and P would be corresponding parts. So right now I have two sides congruent, and if I list the 4 ways, side, angle, angle, and angle, side, these last two require that I have two pairs of angles congruent. I don't have that, so we're going to go ahead and cross those out. That leaves me with side, or side, angle, side. Side angle side would require that the angle is included by the two sides. That would be angle N and angle P. If we had that, we wouldn't need to prove the angles were congruent. So we're going to go ahead and cross that one out. And we're going for side, side, side. And that's right. The third pair of sides is the reflexive side, the side that they share. So the next step in your proof would be that segment MO is congruent to segment MO. And your reason, of course, would be reflexive property. Now, if you take a look at the markings in your picture, you have the three sides of one triangle marked congruent to the three sides of another triangle, and so we can go ahead and make the congruent statement. Why don't you go ahead, stop the video, and see if you can write the proper congruent statement. Okay, here's one version of the congruent statement. I chose to write MOP and MON. You could have had POM, NOM. Okay, again, remember, you can switch up as long as your correspondences are correct, that M goes with M, O goes with O, and P goes with N. Well, now that the two triangles are congruent, we know all of their corresponding parts are congruent, and we can see that angle P should go with angle N. They correspond, so we're just going to go ahead and say angle N is congruent to angle P, and our reason is our new best friend, C, PC, TC. Okay, we're going to go ahead and move on to page 3, example 3. Okay, here's page 3, example 3. We are being given that segment AD is congruent to segment BD. We're also being told that C is the midpoint of segment AB. And we're being asked to prove that angle ADC is congruent to angle BDC, and that's these two guys right here. So, first thing we're going to do is mark the picture. So AD is congruent to BD. Then it says C is the midpoint of segment AB. Well, midpoints break a segment into two congruent segments, so I'm going to go ahead and mark segment AC congruent to segment CB. Okay, so let's get started on our proof. We need our statements, we need our reasons. Our first step is going to be segment AD is congruent to segment BD, and C is the midpoint of segment AB. Our reason, of course, is that's the given. Well, we're going to stop right here. I would like for you to please finish this example, give it a good try on your own, and I will check it in class and see how you did. See you in geometry.